Okay, so yesterday we talked about simplifying rational exponents and radicals. We're going to do the same thing today and talking about dividing and then simplifying from that. And so if you have any questions, make sure you jump on Zoom on Tuesday or Wednesday and make sure you understand how to do that, because we will be moving forward through the rest of the week, and we will be taking a quiz over this. All right, so I'm going to do some examples again today. Again, hopefully you jumped on Zoom and that'll help out. So my first one that we're going to simplify is a rational exponent. We have 216a to the 6th to the power of 3/4. And again, we're going to simplify. So we're taking the cube root of 216a to the 6th to the power of 4. So if you need to separate that, that means the cube root of 216 and the cube root of a to the 6th. The cube root of 216 is 6, and the cube root of a to the 6th, remember that becomes, you're dividing that out. So how many times can you take that 3 out? So this becomes 6a to the 2nd power. But we can't forget, we simplified all of this stuff that was in parentheses, and it was all to the power of 4. So that means 6a to the 2nd times 6a to the 2nd 4 times, right? So if we multiply 6 4 times, we get 1296. We multiply a squared 4 times, we get a to the 8th. All right, next one. So let's say we have 2 times the cube root of 80x cubed, and that's all underneath that radical. And so this 2 is just going to hang out. We have the cube root of 80 times the cube root of x to the power of 3. And the cube root of 80 can be broke down into 8 and the cube root of 10. And again, remember 2 is just kind of coming down, hanging out. So we have 2 times 2, because the cube root of 8 is 2, times the cube root of 10. And then we have x 3 over 3, so it just becomes x. All of your whole numbers come to the front, so 2 times 2 is 4. Your x is whole, so it comes to the front as well, times the cube root of 10. Okay, let's look at another one. So let's look at division. So we have 2 divided by 3 times the cube root of -5. Okay, I have to get rid of this. Can't have a radical in the denominator. So remember, we talked about this yesterday. So we're going to multiply by the cube root of something, right? And if I stop and think about this, I can't break down the 2 and the 3 because those are whole numbers. There's no other cube root on the top, so I can't simplify it from that. So when I think of my cube roots, there's a couple different ways that you could look at this. This also means -5 to 1/3. So I want -5, and I want it to become -5 3 over 3. So I have to do 2 over 3, right? So if I have the cube root of -5, obviously it's in parentheses, to the power of 2. And so -5 to the power of 2. You could also think about how to make this a perfect -5 times -5. This is 25, the cube root of 25. So this 3 is just going to hang out. I'm going to keep it in black. I'm going to cube root -5 times 25, right? And then I'm going to keep the 2 in the top black also, because I'm not doing anything with that. And then I have the cube root of 25, because -5 to the power of 2 is cubed. You could also look at it as the cube root of -5 times the cube root of -5 becomes the cube root of -5 3, right? So there's a 1 here, so this needs to be a 2. And then -5 times -5 is 25. So it kind of just depends on how you see this. So this becomes 2 times the cube root of 25. I can't multiply this 2 on the outside, it's a whole number. And then I have 3 times the cube root of -5 and 25. I multiply those 2 together because they are underneath the same cube root, right? Underneath that same cube root. And so this becomes -125. which is my perfect. So we have our cube root of 25. 3 times, this becomes negative 5. The cube root of negative 125 is negative 5. And so my answer becomes 2 cube root of 25 over negative 15. Okay, let's look at another one. Let's say negative 2 over the cube root of 25. So I need to multiply this by the cube root of something, right? And this needs to be a perfect cube. You can kind of think of that process. You could also think of 25 is 5 squared, right? So I need this to be 5 to the power of 1. Okay, so this becomes a cube root of 25 times 5. This becomes negative 2 times a cube root of 5. And this is negative 2 cube root of 5 over the cube root of 125. So it becomes negative 2 cube root of 5 over 5. Your thought process could be, okay, when I look at my perfect cubes, what could I multiply 25 by to get one of those numbers? Well, the end is 125. So I can multiply 5 times 25 to get 125. You're always trying to become, in the denominator, having that perfect nth root, so it becomes a whole number, okay? Okay, so let's look at another one. What if I gave you 3 times the 4th root of 5 over the 4th root of 27? 5 and 27, I can't simplify that anymore. So I'm going to have to multiply it by the 4th root, it has to be the same, of something. So your thought process here is, what can I multiply 27 by to get a perfect, right? Down here it needs to be a perfect nth root. And this would be a 4th root. You could think of this as the power of 3, 3 to the power of 3 if you would like. Just kind of depends on how you see that. This is 3 to the power of 3. So I can multiply 3. 27 times 3, right, becomes the 4th root of 81. And so this has to be 3 as well. They have to match. So now I have this 3 hanging out, the whole number, and then I have the 4th root of 5 times 3. So it becomes 3 4th root of 15. And then the 4th root of 15 cannot be simplified anymore. And then the 4th root of 81 is 3. Ooh, look at there. We have 3 and 3. So my answer is just the 4th root of 15. Okay, let's look at another one. What if I gave you 3 times the cube root of 2 over the cube root of 4? Now, some of you may be able to see from what we did yesterday, since these are the same cube roots, right? This is 3 times the cube root of 2 over 4. So this is 3 times the cube root of 1/2. So this is 3 times the cube root of 1 over the cube root of 2. So you could do it that way as well if you wanted. And then I still have to get rid of this, right? So if I did it that way, I would have to multiply by a cube root of something to get to a perfect cube. Well, this is 2 to the power of 1, so I could take this 2 to the power of 2, and 2 to the power of 2 is 4, right? So I can multiply this by 4. And so then I have 3 times the cube root of 1 over 4, so that becomes 4, 1 and 4. And then 2 and 4 becomes a cube root of 8, and the cube root of 8 is a perfect, and so that is 2. So let's say, though, you didn't see that. That's fine. I need to still multiply this by a cube root of something to become a perfect. Well, my perfect, I know, is 8. So 4 times 2 would be 8. And so then this is 3 times the cube root of 4. So this is 3 cube root of 4 over 2. Okay, I'm going to go over one last problem. This is multiplication. Hopefully everyone is good with this. We have the same nth root here. So we're going to put this all under one radical. And so this becomes 15 times 50, which is 750. And now we're going to go backwards again. So we're going to look for that perfect cube, which is 125 times 6. And the cube root of 125 is 5, cube root of 6.